Archimedes drained the water in his tub, which makes sense because this line has a negative slope. The amount of water left in the tub is shown in this graph. It's going to ask us for a couple of intercepts, and then it's going to ask us for the slope. The time it took to completely drain, so it started off totally full here and started draining out water until the water was left at 0 water. The time that took was 5 minutes, so it takes 5 minutes to completely drain. It started with 360 liters. So it started up here, the y-intercept, B was 360 liters and 5 minutes. And now I need to find the slope, so I might as well use those 2 points, perfectly good points, to make a slope triangle out of. The rise from 0 up to 360 is 360. The run sideways to 5, this is the rise, this is the run, is 5, and so the slope is 360 divided by 5, which is, let's see, goes into 36, 7 times 72. 72, it's the rise over the run, so it's the liters divided by the minutes. Liters over minutes. So the speed at which this was running out was 72 liters divided by minutes. Should have got the same answer if I picked any 2 points. So you could have picked this point and that point, and boy, that would have been awfully close. I think you probably would have gotten 75. The best idea when you're picking your points to find the slope is to pick points that are as far apart as possible. And so I've picked the y-intercept and the x-intercept and got 360 divided by 5 is 72 liters per minute for my speed. This one's already in mx plus b form. That's my speed. That's my start. So that means he started out owing the bank $9,000, and the rate per month that he's paid it back was $200. So the answers are: you started owing the bank $9,000 and paid it back at a rate of $200 per month. When you are finding the slope with a graph, you do it with a triangle. When you're finding the slope with an equation, you look in front of the variable. And when you are finding the slope from a table, you do subtract, subtract, divide. So the change in y is, I subtract those two, I get 45. And the change in x is 7 minus 1, which is 6. And then so I subtract here, and now I divide. The rise divided by the run. I get 45 divided by 6, which I'm going to have to use a calculator for. So 45, whoops, divided by 6, 7.5, so 7.5 degrees. 7.5. It's what per what? We divided green by purple, right? So it's degrees. Let me highlight. Green divided by purple. Green divided by purple. So we've got degrees divided by minutes. So that's otherwise known as a degree per minutes. So the speed at which this thing is heating up is 7.5 degrees per minute. I can go ahead and finish out my table if I want to find the y-intercepts. So problem is that the y-intercept occurs when x is equal to 0. So I know time and I know the temperature, but it started off at 1 and then 7 was the very next one. So if I'm going to find 0, then I'm going to have to work backwards. And the thing that tells me how fast I go is the 7.5. I'd like a little bit more room for this, so yeah, let me write this in another column. Okay, so because I'd like my table to go all the way down to 7 so that I can double check that everything's working. So I've got time and temperature. I want the 0. That's where my star is. The y-intercepts, where it started. And I know 1 is 2.5. 2, 3, 4, 5, 6. And let's double check. If we did everything right, we should get 7. And when I say do everything right, I mean our slope, we just calculated that it increases by 7.5 every time another minute goes by. So every per minute, then this number goes up by 7.5. So the next one's going to be 10. The next one's 17 and a half. And then 25, 32 and a half. In my head, I'm adding 7.5 every time. And then 40, 47 and a half. So if I have calculated the slope correctly, everything's going right, then I should, yeah. At 7, it was 47.5. So everything is going right. My slope was 7.5, and yes, if I increase this data table by 7.5 each time, then everything's working out. The slope tells me how fast this increases every time the other side increases by 1. So to get where it started, I need to work backwards 1. 2.5 minus 7.5. 2.5 minus 7.5 is, of course, -5. -5. That makes sense because he took this pizza out from the freezer, and things that are in the freezer are less than 0 in Celsius. So this is a frozen pizza, and that's the reason why its temperature was negative. So this equation was 7.5 times x minus 5, because it started out at -5 and it increased by 7.5 degrees every minute. And that is us for this page. Again, to summarize how to find slope and intercept in each representation, using a graph, you find the slope with a triangle, and the intercept is where the graph starts. So this equation would have been 72x plus 360, because it started at 360. Using an equation, the speed is always in front of the variable, and the start is by itself. Using a table, you subtract, divide, will find the slope. And then in order to find the intercepts, we had to figure out where x was equal to 0.